In this video, we're going to talk about comparing means for two independent samples. Independent samples implies that the observations in one sample are independent of those in the other sample. We use the difference between the two sample means, x by 1 minus x by 2, to estimate the difference between the corresponding population means difference, mu1 minus mu2. Two different equations can be used for this analysis. First, assuming population variance are equal. So this is called pooled variance test. Another type will be assuming population's variance are not equal. It is called unpooled variance test. We will focus on unpooled variance test. In other words, we are assuming population variance are not equal. Just as what we learned in other statistical methods, there are a few assumptions we need to check. First, we need a quantitative variable. We need a quantitative response variable observed in each of the two groups. We need independent random samples from the two groups. And the population should have approximately normal distribution for each group. It is mainly important for small sample size, which means the sample size is less than 30. Here is a formula to calculate standard error. Recall that we are assuming the population variance in two groups are not equal. So that's why we have two parts here. One part for group 1 and another part for group 2. And this is the formula to calculate confidence interval. Just like what we learned in other types of hypothesis testing, we need to state the null hypothesis first. So the null hypothesis will be mu1 minus mu2 equals 0, or equivalently mu1 equals to mu2. And the the alternative hypothesis will be mu1 minus mu2 doesn't equal 0, or in other words, mu1 doesn't equal mu2. The mu1 represents the population mean of first population or first group, and the mu2 equals to the population mean of the second population. And this is the formula you can use to calculate test statistic. Here is StatQuant commands for two sampled t-test, assuming the two samples are independent. We use the with summary option if you know sample means, sample standard deviations, and the sample size. We use the with data option if you have two different columns of data. In the StatQuant, you can choose to set up either hypothesis test or confidence interval. Here is side-by-side comparison between dependent samples and independent samples. In dependent samples, we are using matched pair or repeated measurements. And in the independent samples, we are using the samples that are not dependent. In the dependent samples, the sample size must be the same. In the independent samples, sample size may be different or may be the same. For the dependent samples, we are perform paired t-test. In the independent samples, we are using two sampled t-test. And there are some variations to the test. We use what we call pooled t-test if assuming equal population variance. And if we assume the population variance are different, we use what we call unpooled t-test. we can compare the possible hypotheses. They are very similar, except for the dependent samples. We a lot of times we denote the difference as mu d, and for the independent samples, we explicitly states that mu1 minus mu2 equals 0, and versus mu1 minus mu2 doesn't equal 0, and so on and so forth. Last, about the point estimate. So for the dependent samples, we use the average difference of each matched pair, denoted as the capital D bar. And in the independent samples, we are using the point estimate equals to the difference between the sample means as x1 bar minus x2 bar. If we are interested in is there evidence of a difference between the two population means, then if we have dependent samples, the null hypothesis will be mu d equals to 0, versus the alternative hypothesis as mu d doesn't equal 0. If we have independent samples, the null hypothesis will be mu1 minus mu2 equals 0, versus the alternative hypothesis as mu1 minus mu2 doesn't equal 0. If the p-value is smaller than the significance level alpha, then we should reject the null hypothesis. There is sufficient evidence of a difference between the two population means. If the p-value is larger than the significance level alpha, then we do not reject the null hypothesis. We say there is not sufficient evidence of a difference between the two population means. If we are interested in the questions such as, is there evidence that the mean of a population 1 is higher than the mean of population 2, then the null hypothesis will remain the same as the previous example. However, the alternative hypothesis will change. If we have dependent samples, the alternative hypothesis will be mu d is larger than mu 0. If we have the independent samples, the alternative hypothesis will be mu1 minus mu2 is larger than 0. Again, if the p-value is smaller than the significance level, we should reject the null hypothesis and claim that the mean of population 1 is higher than the mean of population 2. If the p-value is larger than the significance level alpha, then we do not reject the null hypothesis and say there is not sufficient evidence that the mean of population 1 is higher than the mean of population 2. The last type of question we may be interested in is there evidence that the mean of population 1 is less than the mean of population 2? Again, the null hypothesis will remain the same. However, the alternative hypothesis will become mu d smaller than 0 or mu1 minus mu2 smaller than 0. We choose either the first one or the second one, depending on whether we have independent samples or dependent samples. And the interpretation is very similar. If the p-value is smaller than the alpha, then we should reject the null hypothesis and say there is sufficient evidence that the mean of population 1 is less than the mean of population 2. And if the p-value is larger than alpha, then we do not reject the null hypothesis, since there is not sufficient evidence that the mean of population 1 is less than the mean of population 2. Another statistical methods we should learn is how we should use the confidence intervals to estimate the population mean difference. The confidence intervals can be used to determine whether there is evidence of a difference in the means of the two populations. If 0 is in the interval, then it is possible that the two population means will be the same. Therefore, there is not evidence of a difference. the interval will consist of a negative lower bound and a positive upper bound. Right, if the interval will consist of a negative lower bound and a positive upper bound, this implies that the zero is in the interval. If zero is not in the interval, then there is a difference in the population means. In other words, the interval will either contain two positive values or two negative values. Confidence interval can also be used to state which population mean is larger than other population mean. If the interval consists of two positive values, then group 1 has the higher population mean. If the interval consists of two negative values, then group 2 has the higher population mean. If the interval consists of one negative value and one positive value, then we cannot say which group has higher population mean.